Welcome back to the 60-day Pentesting challenge. On day 5 we did DNS enumeration and built a list of target hosts. Today on day 6, we need to figure out what software is actually running on those hosts. This is web technology fingerprinting, and it is the step that turns a list of IP addresses into an actual attack plan. Because here is the thing, vulnerabilities are version-specific. Apache February 4th 49 has a path traversal bug. Apache February 4th 51 does not. If you do not know the version, you are just guessing. Let us start with the easiest technique, reading HTTP response headers. When you send a request to a web server, it sends back headers before the actual page content. And most servers, in their default configuration, include a server header that announces exactly what they are. Open your terminal and run curl-s followed by your target URL. Pipe that through grep and look for server, x powered by, and x generator. You might see something like server:jinx/1.18.0, x powered by :php/7.4, x generator :Drupal 9. That is 3 technology versions from a single HTTP request. The server header identifies the web server. X powered by reveals the backend language or runtime. And X generator often names the CMS platform. Now here is an important gotcha. Security-conscious administrators strip these headers. Jinx has a server_tokens-off directive. Apache has server tokens prod. When you see just server:jinx with no version, the admin has done some hardening. But that does not stop us. Different web servers have different behaviors, and we can use those differences to identify them even without version headers. Try sending a request with a fake HTTP method, something like curl-s I-x fakeverb followed by the target. Apache typically responds with a 501 not implemented status code. Jinx responds with 405 not allowed. IIS responds with its own 405 but with a different response body. Same request, different responses, that is a positive identification. Default error pages are another goldmine. Request a URL that definitely does not exist, like /nonexistent-page-12345. If the server is using default error pages, Apache includes the server version and port number in the footer of its 404 page. Jinx shows a simple centered message. IIS has a distinctive template with detailed error codes. Even custom error pages often leak information in HTML comments or CSS class names. Also check session cookie names. If the response sets a cookie called fsessid, the backend is PHP. Sessioned means a Java servlet container. A cookie named connect.sid means express.js with express session. These defaults are almost never changed. For manual checks, headers and error pages work great. But a real assessment needs automated tools that check hundreds of signatures at once. WhatWeb is built into Kali Linux and it recognizes over 1,800 technologies. Run WhatWeb followed by the target URL for a quick scan. Add -3 for aggressive mode, which sends additional requests to trigger technology-specific responses, like requesting wplogin.php to check for WordPress. The JSON output flag lets you save structured results for later analysis. Nmap also helps here. The http-enum script probes hundreds of common file paths. A 200 response on /wp content confirms WordPress. A 200 on /elma.axt means you found an exposed ASP.NET error log, which is a significant finding on its own. Do not skip client-side analysis. The HTML source code contains technology signatures that server headers never reveal. JavaScript library URLs often include version numbers right in the file name, jQuery-3.6.0.min.js. Meta-generator tags in the HTML head section name the CMS and version. Framework-specific markers appear throughout the page. Next.js applications have a div with id__next. Angular adds an ing version attribute. React development builds include React DevTools hooks. A Python script with Beautiful Soup can parse the page source and extract all of these signals automatically. This catches the full stack that a reverse proxy hides. The edge might show Nginx in headers, but the page source reveals React on the frontend calling a Django API on the backend. Document your fingerprinting results in a structured format: host, technology, version, how you detected it, and your confidence level. A version from a server header is high confidence. A version inferred from error page behavior is medium. This structure becomes your roadmap for the next phase, looking up each version component in CVE databases and exploit repositories. Tomorrow on day 7, we are combining DNS enumeration and fingerprinting into a full reconnaissance exercise. We will take a target from zero knowledge to a complete infrastructure and technology map. See you there.